from the College of Architecture and Planning at the University of Colorado, Boulder. He is currently Assistant Professor of Architecture at the University of Kentucky College of Design, where he directs the Critical Software Lab, and a PhD candidate at the Eindhoven University of Technology. Galo, thank you very much for being here.
Thanks, Lucas. Thanks, Enrique, for having me and for your warm hospitality these past couple of days. Um, so just as a brief disclaimer, this is a beta version of a theory that I'm working on called post-intelligence. And so what I welcome at the end of this is some kind of discussion. I'm happy to engage in conversations regarding some of the ideas that I'm going to present today. But really, the whole um, theme of today is to try to answer the question, what is creativity in the contemporary moment when we have access to so many different types of intelligences, synthetic intelligence, artificial intelligence. And my answer to that question is something along the lines of intelligence has become a kind of design problem. And so let's begin with the illusion of intelligence. Back in 2016, 2017, I was working on a project called Architecture Theory Machine. You could access it on Twitter called Theory Machina. That was the handle. And in this project, I was trying to explore the idea of a design language or design theory language. And I was also kind of reflecting on the jargon and the language that is used by architectural theorists. And so I built this Twitter robot that would read the text of K. Michael Hayes' seminal anthology, Architectural Theory since 1968, which is probably one of the most commonly used architectural theory textbooks in architecture school. And I extracted all of the text of this textbook and I fed it into what's called a regular expression algorithm. And so the robots filtered the text and it reassembled itself new theories of architecture and it sort of, pretended to theorize about architecture in a certain way. Obviously, it produced maybe what we call today slop. But I think it was kind of interesting because it was in the pre-slop era. You can see that it started to spit out some tweets that sounded intellectual, that sounded smart, such as the city can be seen as the built artifacts of a set of subcultures, right? That seems like a sentence that makes sense, that is legible. But all of that was pieced together through this algorithm that selected different words and smashed them together in different ways using a structure that would produce legible sentences, essentially. And so the robots was automatic, and so every day it would post one tweet, one theory or a fragment of a theory of architecture. And sometimes it was, it produced some really interesting um, commentary, like Piranesi's Campo Marzo fools nobody as to its reality as an experimental design hidden behind an archaeological mask, right? That doesn't really make sense, but it sounds smart, right? And so what I decided was that this was almost like the production of the illusion of intelligence. And it started to maybe bring up ideas about what do we think is architectural intelligence or design intelligence in some way. Now, of course, this is actually not very new. If we go back to 1975, John Giroux and Warren Julian, they were information scientists. They produced this software. It was kind of a software experiment. It never really went anywhere, I don't think. But it was a conversational design, like building design program, right? So way before LLMs. And this is how the system worked as an example. You would open up the software and it would say, good morning, please type in your name, right? It was kind of like a video game. And you type in your name and then it says, that's great, Warren, but you didn't tell me your surname, right? And so it has this conversational tone. And so you have to introduce yourself to the machine, and then the machine asks you, uh, tells you, we are going to do a design together. I will do the first design, and then you can have a go at modifying the design, right? So it explains to you how the system works in a very straightforward manner, but it starts to almost act like it's friendly as well, right? It says things like, thank you. Um, it says, fine, now we shall set to work on Warren Julian's house. You're going to design a house. And so through this conversation, the system allows you to define square footages, and really it's a space planning uh, software. It wasn't anything that intelligent as maybe the kinds of um, models that we see today, but it would produce things, right? So you would define the square foot of the length of a module, and then you would say how many modules you want. And I think it's really interesting that it was pre-programmed to respond to things like sorry, right? You would say, sorry, I made a mistake. You would type in help, exclamation points to get some help. And then, sometimes if the process is taking too long, it would respond, I'm still working, right? And in the end, you get this ASCII output. This is the house that you designed with this intelligent system, right? Um, but I can't help fixate on the language that is used in this system, because it's almost exactly like the type of language that we encounter now with these LLMs, these large language models, or these conversational AI tools. It's almost a little sycophantic, right? It sort of tries to be friendly in some way, right? And so, in a sense, designers have already, explored this idea of a conversational design intelligence. And so, of course, now when we look at ChatGPT, this is already kind of inherent in in these structures, in these ways of approaching the design of software, right? We're creating systems that um, are humanized. They use our own colloquial terms. They're kind of friendly in a way. And what's interesting about models like ChatGPT is that they will never say no to you. They always say yes, right? That's the sycophantic kind of attitude that a lot of people are kind of reflecting on. And of course, the reason that they say yes is because they want you to keep using the tool. If you say no, or if they say, no, I can't do that, then you're going to stop using the tool and you're going to stop paying for that tool. And so there's a kind of political drive underneath some of these systems that maybe is being masked by some of the pleasing language that is being used, right? And so then you start to think about, what are these things actually intelligent, right? The software that helped designers lay out this space planning strategy, that wasn't intelligent. That was pre-programmed. So all of the phrases, the responses that were available to designers, or that were presented to the designers, those were essentially made through flowcharts, right? So if you input this word, then it would output this response. So it was a very simple input and output kind of tree branching structure. And so then if we get to the era of, let's say, image generation or machine learning models, uh, maybe they start to be a little bit more sophisticated, but it's still I think we should still question whether this is actually intelligent by the traditional metrics of intelligence, right? And so I really like this tweet that says, if you had to show a toddler millions of images of a cat before they could reliably identify a cat, intelligent would not be on the list of things you would consider that toddler, right? And so, is a system that is trained on a particular set of images to recognize an image intelligent in some way, maybe not in terms of human intelligence, because if you think about a toddler doesn't just learn by looking at images of a cat. A toddler learns by interacting with in social circles, right? A toddler interacts with their parents, their family, their friends, with objects in different ways. And so they're not just exposed to an image of a cat to understand what a cat is, but they're exposed to the whole network of relations that exist around cats. And this idea that a cat is actually similar to other things that are out in the world as well, right? And so, you know, if we go back to some of the early machine learning experiments that you may have heard of, like Deep Dream, for example, this is the problem that they were running into, is that when you train one of these models in to specialize or to recognize just one category of images, for example, then all it knows about the world in terms of general intelligence is that everything must be made to fit the model of the images that they were trained on, right? So Deep Dream, famously, there were different versions of it. One was trained on pictures of dogs. And so then if you asked it to generate an image of a dog, or if you asked it to generate an image of a house, it would try to make the image of a house look like a dog, right? Or conversely, if you gave it an image of a house, it would try to find the dog in that house, right? Because it's always searching for what it recognizes. It's always searching for the dog. And here, I think you can sort of see that the effect of feeding an image into the system that only knows one thing, like a dog, it tries to turn everything, it just tries to turn everything into a dog itself, right? And so then, is this intelligence? You know, is this a kind of intelligence in some way? Who knows? And so intelligence itself recently, in recent years, has become a design problem. And really, designers are not actually involved in a lot of the design problems of designing intelligence. But in order to design intelligence, you have to understand, you have to have a model of intelligence. You have to sort of think about where intelligence came from historically as well. And so the traditional models of intelligence that we have been most familiar with come from the scientific revolution in the sort of 1600s. They come from the Enlightenment, right? So the idea of the scientific method, that you can solve a problem by investigating and creating a hypothesis, doing an experiment, repeating that experiment, verifying those results. And the idea that that process is a kind of enactment of intelligence that proves that you are doing intelligence, you are being intelligent, right? That was really how we started to understand the world, right? We started to understand the astronomy in that way by being very rigorous, methodological about the things that we are looking at. And eventually in the Enlightenment, the Enlightenment was maybe the kind of the time when intelligence became very much codified, right? And the Enlightenment is sometimes called the age of reason. And so reasoning was really the thing that embodied intelligence. This idea that you question something and you investigate and you try to find answers to a question in a very methodical way, establishing a process for investigating and then analyzing facts, comparing data, and verifying that the facts that you found are most likely true. That is really a model of intelligence that has been dominant for most of the past 200 years. And so when scientists and doctors were studying the brain in the late 1800s, they started to discover neurons. And so for them, for Santiago Ramon y Cajal and Camilo Golgi, these two, they're probably the first neuroscientists. They're kind of credited with the discovery of neurons in the brain. In a way, I think this is really interesting in a kind of design art context, because the reason that they discovered the way that they discovered the neurons is actually by drawing them. And so Camillo Golgi actually was invented a specific technique for staining brain cells, and the stain of the brain cells allowed some colors to pool in specific areas. And so they would create these dark areas, which then they hypothesized, like Santiago Ramon y Cajal, he hypothesized that those were actually discrete processing units inside of the brain, that these dark areas were almost like individual cells that would process information in the brain. That was the kind of hypothesis. And so they made these beautiful drawings of neurons based on this staining technique that they had discovered. And so they started to think that maybe the way that we think is really by putting information through this neural network. And there's something interesting in the problem of representation here, right? That in order to actually achieve or get at some idea about intelligence, you have to draw it. You have to draw the neurons to understand intelligence. Now, of course, later on, we have microscopes and we have MRI machines, and we have a lot of technology that allows us to verify some of those hypotheses. And so this is actually an image of a brain cell. I think this might be of a rat. I don't think this is a human brain cell. But it looks pretty similar to the kinds of drawings that they were doing of these brain cells, right? And so you have these discrete units, these neurons, and then you've got these connections, right? And so the image of thinking as a network actually became a dominant theory in the 20th century, right? We decided that humans think through discrete processes, right? And so this was actually really, really important for the development of synthetic or artificial intelligence, because once we have this image of what we might think intelligence looks like, then we can make a machine replicate that in very specific ways, right? Because neurons are discrete, and binary calculating machines are also discrete. And so the representation of the neuron actually became a kind of dominant paradigm for the discussions about synthetic intelligence, for any kinds of investigations related to artificial intelligence. And so, all of this eventually led to the development of convolutional neural networks. And even just the idea of a neural network as a term is really, really interesting, mostly because it becomes almost like a piece of media, right? This becomes a medium through which you can represent things and you can kind of manipulate things, right? And so for anybody that knows how convolutional neural networks work, they kind of try to mimic the way that the neurons kind of fire in the brain, so they're discrete units. And so this is an example of a process for image recognition, for pattern recognition. And so the neural network is basically this part of the process. But what happens is that you take a piece of information, in this case an image, and you break it up into smaller chunks that can be analyzed. And then those smaller chunks are compared to other chunks that have been already pre-programmed into the system. And then the neural network, each neuron is basically a kind of check, right? It's a function that says, how close is this image to something that I already know? So similar to the way that Deep Dream recognized the images of dogs. Here, if you want to recognize an image of a panda, you have to feed it into a system that actually already learned what a panda is. And so then it will recognize the difference between maybe a raccoon and a panda, or a red panda and a panda, maybe, depending on how many pre-programmed pieces of information it has, right? And so if you look at closely at the images of sort of synthetic neural networks, you can sort of see that they start to approximate a little bit of that that discreteness that was drawn, back in the 1800s, right? So each of these is basically a neuron, and then that neuron has to make a decision, has to process some information, and then send it on to another neuron for processing. And then that neuron also sends it to another neuron for processing. And so in the case of, let's say, convolutional machine learning, image recognition, neural networks, a neuron is basically in charge of processing just a group of pixels. And so it starts to read the group of pixels, and then it starts to process these. And all of these systems are kind of based on the idea of large numbers, right? The more numbers that you have, the more data that the system holds, the better it will be able to discern the differences, the subtleties. We call these weights, the subtleties between pixels, right? And so this is the kind of classic example of a neural net, a program, a software that recognizes numbers. And so the intelligence here is this idea that, okay, so if you train this neural net to recognize the numbers 1 through 9, the goal is to have the system tell you, is this a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? What number am I looking at? But it starts by just breaking the image into fragments and going neuron by neuron. First layer, breaking it up, looking at anything that has maybe high contrast, right? It tries to find an edge, right? And then as it finds an edge, then it tries to move it to the next processing layer and the next processing layer until hopefully the weights and the parameters of the neurons are set exactly right so that it can output a 9. So there's this abstraction of neural processes that maybe isn't as chaotic as the processes that were drawn from the brain, but it's still a similar analogy, right? And none of these systems could really work without the GPU. So if you understand, if you've heard, GPUs, like the GPUs that are used in graphics cards, these GPUs are super important because it allows us to dedicate processing power to each neuron. So computers now are starting to process information in parallel. And because they can process this information in parallel, that means that one processor or one core can be dedicated to one neuron and another neuron, for example. And so all of these calculations, especially the calculations in each layer, are all done at the same time. And that creates a pretty big problem. And that is really the problem of non-determinism, right? Because what happens when you process information all at the same time, how do you know which came first? And does it matter which came first, right? And in GPUs, depending on the manufacturer, there's different math tolerances that are embedded in the GPU. And that actually kind of messes up a little bit of like how the neurons process at each layer at the same time, right? Because nothing can actually be that simultaneous. Even if they're processing at the same time, some of them arrive at an answer faster than others. And that basically means that even if you put the same input, there's no guarantee that the output of that layer will be the same. And so this is a paper that was written last year about the problems with LLMs, because I'm sure you have probably encountered the non-determinism phenomenon where you put in the same prompt into ChatGPT or something, and it outputs something different every time, right? That's non-determinism. And if you think about mathematics before LLMs, math was pretty deterministic, right? You would have an equation, and whatever you put in the beginning of the equation, you know you would always get the same output, right? That's determinism. But because we're now doing parallel processing at such a large scale, now we're in the situation where non-determinism is actually almost like the most popular way of computing. And that's why, for example, LLMs are really bad at math. Like if you've ever had it try to calculate numbers or do some kind of complex equation, it's not a calculator. It's really this statistical processing that is all weighted and based on probability, right? So the way that I think scientists have tried to solve the issue of non-determinism is by training systems to understand the probability of what's going to come next. And so this brings me to this question of multiple intelligences. Because all of a sudden, if you stand back from a lot of the tools that are using neural networks or they're using parallel processing, I think we have to start to question what is intelligence in the contemporary moment, right? Because all of a sudden we're not really approaching intelligence in the same way that we have been used to, right? It's a little bit different. These systems are different than what we're used to. And the math example is probably the easiest way to recognize it, right? Because we are used to having a math equation where you put in something in the input, and then you know that if you whatever you put in the beginning, you're going to get something similar, or you're going to get the exact same result in the end. But now, there's no guarantee of that. And so what is intelligence? What are these models of intelligence? You know, in a way, this non-deterministic model, I think, is a different kind of intelligence that we have really never encountered before. And so, you know, there's people that have been looking at, you know, ways of describing these new types of intelligences, right? And so this recent book by Blaise Aguirre-Ayarcas, What is Intelligence, came out of Google research, and it really talks about how intelligence is actually prediction. And so they go back to, you know, biology, to kind of ancient creatures that evolved in particular contexts. And they make an argument that intelligence, that this kind of intelligence that is associated with LLMs and generative AI systems, for example, these are actually a type of predictive intelligence. And so they're saying that the intelligence that is embodied by these systems is the ability to think about what comes next, right? And so a cell evolved because it somehow started to predict what was going to come next, right? And so like a plant, for example, grows towards the sun because it knows that if I grow in this direction, I know I'm going to get more light, right? And so the plant is intelligent because it can predict where it can get more light. And so there's you know, a little bit of reasoning there as well. And so they're trying to make an argument that maybe intelligence in this sense really just boils down to a sophisticated way of predicting the future in some sense. But in the 1980s, there was also this book that came out called Frames of Mind by the sociologist Howard Gardner. And he put forth this theory of multiple intelligences. And I'm sure some of you have probably heard something about multiple intelligences, because this is really when the idea of emotional intelligence, social intelligence, musical intelligence, this is when these intelligences became, well, they became known, right? Because before this, intelligence was really measured through IQ, right? You would have an IQ of 100 or You would have an IQ of 120 and you would be a genius or something like that, right? And it quickly, scientists and cognitive scientists, cognitive behavioral scientists, for example, they realized that IQ was not really a good measure of intelligence because, there are people that are prodigies in music. Right? They can play the piano really well. There are people that are, that have interpersonal intelligence, that are really good, that have really good social skills, that can almost like manipulate people or something. There are architects and designers that have visual spatial intelligence, right? And so Gardner proposed that there's not one singular model of intelligence or one singular metric for analyzing intelligence, but actually that there's a whole world of intelligences out there. And since then, there have also been more theories of even more multiple intelligences added onto this, right? Now, the one that we're probably most familiar with is logical mathematical intelligence. This is this idea of deterministic calculations, for example. And so logical mathematical intelligence, very simply, is the idea that you can reason through numbers and logic, right? So that if I have 5 rocks and somebody has 10 rocks, logically we can conclude that that person has more rocks than I have, right? And so he started to break down these types of intelligences very simplistically, all the way to that kind of an example. And so to this, I would add the predictive intelligence that we talked about with LLMs. And I would also suggest that Gardner is not, he's a scientist, he's reflecting on what he's researching, but I would also say that he's kind of designing these intelligences in a way, right? He's breaking these components down and making an argument that these are almost a kind of design problem in itself. And so what I'm trying to argue for with this idea of post-intelligence is that we are now no longer in an era where we enact the same type of intelligence that we have been used to, right, since the Enlightenment. We are no longer really concerned with reasoning in the traditional sense, but really what we're doing is actually more removing ourselves and kind of curating intelligences very much in the same way that that Gardner was doing. And so I've developed this work in progress rubric for understanding the difference between previous models of intelligence and where we are now with this idea of post-intelligence. And it can really be broken down into goals, motivations, priorities, processes, tools, expectations, and in some sense, the idea of the self as well. And so I'm just going to run through this using some examples, right? So if the primary goals of intelligence in the traditional sense have been problem solving, post-intelligence replaces problem solving with accumulation, right? We make more things rather than better things because we've got models and we've got tools that already do the intelligence for us. And so we can just kind of brute force attack anything that would have in previous times been addressed through reasoning or through problem solving, right? And so an example of that would be the Coca-Cola ad. I don't know if you guys saw this Coca-Cola ad that was released last year. It was generated with AI. And in this Coca-Cola ad, the creator said that they generated 70,000 videos and clips, like little clips, using AI systems in order to make a 2-minute video. And I think that number is incredibly daunting, right? Like you have to think about what does that mean in terms of like intelligence? Is that like actually the enactment of intelligence, or is that just brute force problem solving in some way, right? And so for me, this kind of problem of quantity and brute force becomes really important. In terms of motivations, if intelligence was motivated by curiosity, like in the Enlightenment, for example, trying to discover things about the world, then post-intelligent thinking is motivated by the status quo. We seek to maintain the systems that exist rather than replace them with something else that might be unknown. And this is probably part of the convergence. Maybe it's a little bit related to accelerationism, but in a way, like we are sort of more motivated by keeping the structures that we have rather than try to reinvent new structures, right? And in my opinion, this sort of results in almost like an idea of things being good enough. And I love this comment by a software developer that says, code doesn't have to be perfectly crafted the way that it was pre-AI. Shipping velocity matters more than perfection. And so here you start to wonder like where the motivations for these synthetic intelligences are coming from. They're coming from corporations, they're coming from, investors that have invested a lot in these companies. And so the era of synthetic intelligence, I think, is really changing the motivations at a large scale. And you can very clearly see it happening in software development, for example. And so this idea of vibe coding, of coding with an assistant, in some cases actually produces code that a traditional software developer maybe wouldn't have produced in that way. Priorities. So if the priorities behind intelligence were to produce new knowledge, as exemplified by the modern university, post-intelligence prioritizes remix knowledge. Novelty is not based on uniqueness, but repetition, right? And so you can see, for example, the growth of the Star Wars universe. We used to only have 3 Star Wars films, and then we had 6 Star Wars films, and now we've got 1 million Star Wars films. And I think instead of producing, like using this technology and being creative by producing new types of media, the age of post-intelligence actually reinforces the production of existing media, of remixing things that we know, things that are familiar to us, because we have the tools to achieve that. Processes. So if processes associated with intelligence have historically been reasoning, those associated with post-intelligence are built on scale. So we don't use optimized processes because it doesn't matter if things are optimized, because we have more, more computing, more compute, more storage, et cetera. We use the brute force approaches that I've talked about before. And this actually, has its roots in earlier sort of paradigms, like the search don't sort paradigm from Google, where it doesn't really matter if you organize your email into folders. You can always just search for it. And I think it's kind of ironic that search functions have actually started to deteriorate in some recent years as well. Tools. So if the tools of intelligence were based on the scientific method, where a set of operations requires replicability and repeatability, the tools of post-intelligence are based on statistical probability. Instead of deterministic tools, we now use indeterministic tools where the same inputs produce different results, right? So this is probably the biggest difference, as I already mentioned, is that the tools of intelligence are now not deterministic. So you don't know what the output of any given function or any given process might be. And here's where maybe I think we have opportunities as designers and artists, because indeterministic systems actually allow room for unexpected results, right? And so the deterministic processes maybe were used to approximate natural phenomena or something. Indeterministic processes actually produce more chaos, but maybe that's more interesting in a way. And so I know some of these maybe sound kind of pessimistic, but I'm trying to find the opportunities to act on these. So for expectations, if the expectations of intelligent processes have typically been insights, revelation, or some form of truth, then the expectations of post-intelligence processes are familiarity, adequacy, and predictability. Searching for truth is too risky right now, right? And so we're kind of in the post-truth era, And post-truth, I think, feeds directly into the kind of post-intelligence era because in a way, the kind of creative processes that are involved in producing post-truth narratives reflect maybe ideas about indeterminism and of not using reasoning in a particularly traditional way. And so I think for us, it's really much more satisfying to get something that looks familiar, right? And so this is actually, I mean, this is back in Midjourney days. I don't know if anybody uses Midjourney anymore, but there was something kind of interesting when you would ask Midjourney to produce a plan, because it produced a plan that was familiar, but then there was something a little bit off, right? There was something a little bit weird about where the kitchen was. You know, the kitchen is in the garage, or actually the kitchen is in the front door, and so, you know, I think it's kind of comforting and maybe in a way reassuring that these systems are producing something familiar, but they're just a little bit off. But our expectations are that these systems will be able to produce things that we already know. And lastly, this is a little bit more, you know, identity oriented, but if intelligence has often been associated with self-actualization, this idea of personal growth, fulfillment, post-intelligence is really about self-preservation, right? It's about maintaining your identity, protecting your personal health, your mental health. And so, you know, I kind of suggest that achieving enlightenment is difficult. Like, well, maybe we don't want to achieve enlightenment anymore. Maybe we're just happy to preserve our own identity in the world of this, you know, post-intelligence system or synthetic intelligence and AI. And so you can sort of see this. This is a prompt that allows the user to sort of constrain the writing in a way that preserves academic tone and it preserves that kind of identity. Because we all know that ChatGPT and these LLMs, they have their own way of speaking. And so now the self-preservation is like, how do you use a large language model, but with your own voice? How do you preserve your own voice and not have you turn into ChatGPT voice? You know what I mean? And so this is the kind of conclusions that I'm getting to, is that creativity now is a type of consciousness or awareness, a kind of hyper awareness of intelligence, rather than the enactment of intelligence. Like it doesn't really matter if we enact intelligence, like we don't reason, we don't problem solve ourselves, but we can now sort of step back and deploy intelligences as we need to, right? And so I love this image of remote login, but maybe we can replace this with like, this is us, and then these are intelligences, right? So intelligence is no longer here, it's like, it's here. And so what are some of the opportunities there? I mean, I think maybe we can start to collaborate with some of these intelligence, and maybe to create is to curate intelligence. And so now we can kind of collect intelligences that predict things. We can collect intelligences that reason, maybe collect intelligences that somehow can work with music and work with maybe other models of looking at the world, right? I think spirituality is also a type of intelligence that Gardner talks about as well. And so we are now these curators of intelligence as artists, as designers. And I think that's a pretty big responsibility, because that basically means that we're also designers of intelligence. And even though we haven't been involved in the decision making behind the tools that are widely used, I think we can start to play a role in designing intelligences in some way. And so I just wanted to end with a couple of examples of my, like, let's say, post-intelligent work, which, again, I would describe as work that accepts that intelligence is now transformed, right? So post-intelligence basically is a way of categorizing work that comes after the rise and the ubiquity of synthetic intelligence systems, and explores that in the same way that post-digital art, explored ideas that came after the digital, or the ubiquity of the digital, or post-internet art, post-internet artworks, post-internet theories. Those started to critique the ubiquity of the internet and the aesthetics of internet protocols, for example. Post-intelligence art talks about intelligence from this kind of curatorial design point of view. And so this, for example, this is a very short little project. It's kind of a part of a larger project where I'm building a video game with um, some coding tools like Claude. And this is just an exploration of a UI system. And so I asked Claude to come up with a low resolution user interface set of components. So this is a library of components that I've been developing with Claude. And so I am not designing the aesthetics itself. I mean, I gave it a library that I had also developed with Claude for text rendering. But then it went off on its own, and it sort of pieced together all of these different components. And they're all modular components, so they can be used in the video game that I'm working on. And in a way, I was actually pretty excited and pretty happy with some of these results, even though maybe they do look like things we've seen before. You can also start to remix some of this. So this isn't just the end, right? And I think that's maybe one of the opportunities that we have with these post-intelligence systems, is that I don't think using these tools is enough. You have to sort of take them somewhere else, right? You have to evolve and produce something different. And so another thing that I've been working on is building my own visualization engine and my own game engine, partly for this video game, but for also other artworks as well. And so this engine is a kind of pixel perfect engine. And so if you've ever used any 3D rendering tools, you'll see that it's very difficult to get pixel perfect lines. These are more low resolution, and it's very hard to get that perfect pixel line, because modern systems blur the line and they make it smooth. And so I've been working with Claude, for example, to build an engine that is that preserves the crispness of the pixel, and also uses a specific kind of projection that is used in pixel art, so that there's very little distortion. And so these are some outputs of this engine. Is there another? So it can also handle images as well. These are textures that are mapped onto my pixel perfect geometry. And really, I'm working really hard to try to get these pixels to be very, very crispy and recognizable, which is kind of interesting, because a lot of software just wants to hide the pixel, and I'm trying to bring it to the fore. And so I would characterize this as post-intelligent, in the sense that it really is a collaboration. I'm curating the intelligence. I'm tweaking the kind of knobs and the levels of intelligence in a certain way, so that I can represent something in a way that maybe I haven't seen before. And so this is an artwork, digital artwork that I did last year. It's called Dioramas. And Dioramas was the first kind of test case for this game engine. And so I also worked with Claude in this project to combine artificial life systems. And so you see these are kind of like biomes that are pixel perfect. So all the trees are made of like little pixel sprites, and then all the creatures are programmed to using an artificial life algorithm. Like there's a version of flocking, a version of attraction and repulsion. And so you can see that it kind of feels like this landscape is alive. The birds are also flocking. And so this actually also taps into previous models of intelligence in a way, from like the 1970s and 80s, when video game designers and visual effects specialists, they were trying to replicate natural systems and try to create like agent systems for video games. And so I'm using some of these classic algorithms, but I'm not programming them from scratch anymore. I'm using Claude to kind of help me combine these into a holistic environment. And so this is just another example. There are hundreds of these. Right? So this is a generative artwork, meaning that it's blockchain based, so that if you mint a hash on the blockchain, it generates a unique composition for you. And so there's probably like 900 of these that have been generated so far in the past year, and they're all pretty much unique. And so there's a lot of different parameters that are involved here. But for me, I'm still looking for the opportunities. I'm trying to figure out how I can be a curator of intelligences and still maybe be a little bit optimistic about where we are in terms of like the drastic transition from traditional intelligence to post-intelligence. Thank you.
Hola. Oh, ¿ya estás? Ok. Em, bueno, Galo, gracias. Lo bueno es que hablas español y hablas inglés. Digamos, seguro es todo esto lo pudiste explicar mejor en inglés, pero si alguien tiene una pregunta, una duda, pueden preguntarle en español y él puede contestar. Eh, yo a lo mejor tengo algunas preguntas porque quiero preguntarte, well, should I ask you in English maybe? Or,
No,
yeah?
no,
Okay.
igual. A lo mejor respondo en inglés, pero sí entiendo.
Ok, perfecto. Entonces, quería preguntarte un poco eh, sale un poco de tu plática, pero todo lo que se requiere detrás para poder lograr como una inteligencia artificial, que serían los data centers y toda esta infraestructura, eh, ¿cómo, sí, bueno, podrías reflexionar un poco en eso y comentarnos cómo, porque creo que está súper interesante las implicaciones de cómo entendemos la inteligencia, eh, cómo podemos generar creatividad, ¿no? Con pues esta curaduría que dices, pero también, pues, cómo se balancea eso con lo que se requiere para poder lograrlo, ¿no?
Yeah. I think that the biggest problem that we are encountering with the artificial intelligence, the way that it has been deployed and the way that it has been released to the public, is pretty problematic, right? Because the infrastructure required is way too intense, and the systems that allow for these infrastructures to exist and be built are very extractive, right? And so we don't have, unfortunately, there's really no alternatives that we really have to build different types of infrastructures. I mean, I think we should, as designers of the built environment, I think we should probably advocate for renewable resources, for ethical construction, ethical practices in the construction of infrastructures, right? And I think that maybe eventually we could have a collective mass, but right now it's these infrastructures and just the companies that have pioneered AI, they follow the mentality of move fast and break things, no? And that was the Silicon Valley ethos, from the late 2000s. And because they move so fast, they don't care about the ethics and they don't care about the consequences. And so they found a technology that was great. And actually, they found this technology. The LLMs were discovered, and a lot of people didn't really know how they worked. Even the people that discovered them, they were like, "Oh, it works," and they just kept going, right? And so I think reflecting on this idea of post-intelligence means actually slowing down a little bit, and when you curate, you don't just select randomly. No, when you curate, you think very carefully about what is what you're going to incorporate, what you're going to select. You know, um, and so I think that's how maybe we can gain a little bit more agency, a little bit more control, and not just feed the machine that that is just building as fast as they can because they need to make money, you know. And so there is an ethics, and it affects us in the built environment as designers and architects and even just practitioners, users of software as well. Um, so I think the reason that we need a theory is because we need a way to talk about some of these issues in an intellectual way, um, rather than just saying I'm pro AI or I'm anti AI. No.
Hola. Um, Thank you so much for your speech. Was incredible. I have a question. It's more about what is happening in USA. You know, like we were listening about the work of the work of an architect. Now it's not. Lo voy a decir en español. As I'm translating in. Okay. El trabajo de un arquitecto ahora no es reconocido como un trabajo profesional en el término general, que no pertenece específicamente como un abogado y esto como que nos pone en una posición delicada, vulnerable, porque pone en crisis como ese tema de la credibilidad, ¿no? Como que ya no es legítimo eh, pensar que nuestro trabajo tenga esta importancia a nivel profesional. Y no sé si esto, desde que cambió, o sea, hace poco, menos de 6 meses, has podido ver unos efectos o en general, en tema más cultural que no específico en términos de trabajo.
Yeah. I think, I call this a theory of creativity, technology, and labor for a reason, because I'm really interested in the value of labor and how we maybe can bring up the value of architecture and design. Because right now in the US, and maybe we were talking about it here too, it seems like the value of architects is very low. Like everybody thinks that they can do this design themselves, right? And in terms of like the professional field, you can really feel that in the US and in big practices and small practices as well. Everybody's always making their services cheaper and cheaper and cheaper until they don't have any value. And I think AI plays a very critical role in this because it also allows for this idea of getting satisfactory results. And so how do we maybe advocate for our value? And honestly, I think it's really about organizing, and really, I think architects need to kind of come together, and there's talks about unionization, and I'm very pro unionization because it's really the only way to advocate for any kind of rights or change in the professional field. There used to be, in the US, there used to be a professional architects union in the 1930s. And they were able to lobby the government to get higher wages for drafters that were working on big municipal projects in the 1930s. And then that union actually was dismantled because of the anti-communist persecution. So the McCarthy era in the 1950s, they went after anybody that was pro-union and said, you're a communist and you can't be organized anymore. And so it's taken us a long time to come back to discussions about organization, but I think it's the only really way out is to form collectives and to work collectively to fight for better rights. Because since the 1980s, at least in the US, the profession of architecture has gotten rid of a lot of protections in terms of like antitrust laws and codes of ethics for practicing. And so that's why you see a lot of architects that don't care about labor and They build a fancy building in Abu Dhabi or something, and they don't care that the laborers are dying because they don't have a code of ethics. And so I think it fits into all of this, and I think it's really important for professionals to have a code of ethics, to listen to collective voices, and to have intelligent opinions on some of these tools. Because otherwise, if we're just too independently minded, we're always going to be devalued, because there's always going to be somebody else that comes in and says, I can make a design for you with ChatGPT for $50, right? So maybe that addresses a little bit of that.
Okay, we have una pregunta más.
Bien, gracias. Es muy interesante ver todas las herramientas y justo quisiera conectar un poco la idea de herramientas con todo este tema de ética. Alguna vez, porque una de las formas que se ha mostrado de encontrar alternativas a estos dilemas éticos es tener también herramientas locales o herramientas independientes de modelos externos, ¿no? Me gustaría saber si has explorado, si está en tus intereses, si piensas que es algo que vale la pena como explorar por ese lado, ¿no? Sé que has mencionado cloud y demás, pero también, bueno, no sé, ¿qué acercamiento tiene respecto a eso?
Yeah, so I've been using some local AIs. I use Comfy UI for some video experiments, some text to 3D in my local computers. And I like that because it feels more personal. And so I'm trying to maintain the personal connection to the tools that I have, because they're like my paintbrush, And if you have your favorite paintbrush, you have your favorite pencil, you have your favorite notebook, sketchbook, that it feels good to work with that, And so if I depend too much on external tools, I don't feel that connection. So Claude is really the only one, maybe sometimes ChatGPT for small things, but I do have Olama running on here with ChatGPT open source. It's not that as good as the online model, but I feel a little bit better having these things on my computer because I have a little bit more control over them. And sometimes these things will go down, right? Because data centers are also not super reliable anymore. And I don't want to be fully dependent on subscription services, remote virtual things. I'm kind of traditional, but I'm also of a generation that grew up with personal computers, right? And so I feel like I need to be able to install something on my computer. I need to know where my files are all the time. I use the cloud a little bit, but I don't know, for making these are such personal works for me. And design, I think, is more personal, and I want to maintain that. So that's my way of maintaining that.
Okay.
Hola, Galo, muchas gracias por la presentación. Mi pregunta es muy específica y tiene que ver con el término de post-intelligence o inteligencia, post-inteligencia. Si hay bibliografía sobre esto y en qué medida se vincula con la corriente filosófica, ontológica del posthumanismo. O sea, porque sí que me da la sensación de que tienen puntos en común, si es una deriva de esto, en tanto, bueno, si el posthumanismo interpela al sujeto, quizá la postinteligencia interpela la inteligencia de ese sujeto, y bueno, si el término está en construcción, porque entiendo que no es una corriente per se, y no sé, si sabes si es así o no.
Yeah, so the post-intelligence is my term. I invented it, based off of post-internet and post-digital. Yeah, I've been thinking a little bit about post-humanism, but I like the term post because it's almost like we're in a post era, right? But post in this sense is a kind of like meta. So it's a meta awareness of what of intelligence, right? So in the same way that post-digital is a meta awareness of the digital, in a way, maybe post-humanism is also a meta awareness of humanism to a certain degree. And so I'm really, I think it's coming from media theory more than it is from philosophy, but I think it does have a lot of things in common in terms of, let's say, this idea of a kind of provisional theory that asks us to reflect on the contemporary moment, because a lot of the post theories and post philosophies are critiques of the Enlightenment. And so this itself is very much a critique of the Enlightenment in terms of categorical thinking, in terms of deterministic thinking, right? Because the scientific method is all about replicable results. And so if all of a sudden we have a way of thinking, a way of problem solving that doesn't produce replicable results, then the Enlightenment methods they don't apply, right? Like they're useless kind of. And so, yeah, I mean, it's a work in progress, but I'm thinking a lot about what it means to produce a kind of contemporary theory, knowing that there's a lot of other theories available as well.
Yeah.
Does anyone else have a question? What? Maybe one last question from me. Because your these this framework that you've presented as post-intelligence, that I think is correct on your part to say that it's a reflection on the contemporary moment, because not all of it sounds so appealing. Like, for example, this idea that, okay, no, it's no longer curiosity, it's accumulation. Was the opposite? Or I forget what the
It's curiosity.
So, for example, I think about that and I say, well, I like to be curious, right?
Yeah.
And this self-preservation, or I don't know, these other ideas seem almost to kind of have a continuation of maybe motivation, capitalistic undertones, like self-preservation, accumulation. And so my question for you is, do you think that these tools, and even postulating this theory or framework, could start to maybe question or put into check some of these, I don't know, neoliberal capitalistic approaches to the economy, such as how data centers are built, or what's the purpose of accumulating information, property, etc. I don't know.
Yeah.
It's kind of broad, but
yeah, no, it's very much I'm very much positioning myself as a kind of anti-capitalist theory, or well, not anti-capitalist, but a critique of capitalism, right? That underlies everything. Mostly because as Mark Fisher kind of said, it's very difficult to escape capitalism. And so even if you're thinking about creativity and all of that, the specter of capitalism is always there. And so I'm not suggesting that curiosity is gone. Traditional intelligence still exists, right? And science still will follow the scientific method. Engineering will still follow the scientific method. Like traditional intelligence is still there. But now on top of that, we've got post-intelligence, I think. At least I'm trying to make that argument. And so if you were wondering why no one really cares about perfection anymore in programming, this is why. So, but also you can't break away from the whole network of relations, of the influences of power, of neoliberal thinking and motivations, and then of course accumulation is also a big critique, right? Because it goes back to this whole idea of who builds these data centers, right? What is their motivation? And their motivation is to just keep the stock ticker kind of going up and up and up. And so the only way that that can actually happen is through a process of accumulation. And so then I think we need to reflect on, like, are there any alternatives, right? Because I think post-intelligence is generic, but these are the conditions that have led to a new model of intelligence or new perspectives on intelligence. So it's always there. I don't have any answers.
Okay. Well, thank you very much for your talk. Thank you for coming all the way down to Mexico to join us. And,
Yeah, thanks for having me.
yeah, well, let's give him an applause.